All right. So I want to kind of just come back to the idea of integrated pest management and this idea that in sustainable management systems, we're not just kind of going in, guns blazing on pests. We're developing a strategy that is multi-layered and multifaceted, meaning that we start with things that are just cultural practices, things that we should be doing as good farmers. Things like good site selection, good plant selection, good sanitation practices, and crop rotations, things so that we don't saturate the landscape that we're working in with a particular pest. So growing the same thing in the same field over and over and over again is going to help pest populations build over time because there's always the same resource there. And you're going to be selecting for specialist pests that really focus on your crop in general. So by things like rotation or sanitation is another great thing. Like sanitizing your tools is a really basic way of not transferring disease from one plant to another. And then things like plant selection, when you're thinking about plants that you want to buy, things that are if there's genetic lines that have been bred for resistance, things like powdery mildew and things like brassicas and tomatoes and things like that. If there's varieties that have those resistance already, that kind of sets you up for success. If you're a beekeeper like I am in my other professional career, that's the same thing is selecting good queens for varroa sensitive hygienic behavior. You're setting yourself up for success through a genetic pathway. Now, when we're moving up this triangle, we're incorporating new strategies, but as we go up, we're also increasing risk to the environment and to ourselves. And we go from a more preventative standpoint to a more interventive standpoint. And so we move through the triangle, we go through things like physical and cultural, or excuse me, physical and mechanical means. So things like traps, barriers, mulches, those types of things. And then as we get up into the biological area, we start getting into this area where we start incorporating organisms into the landscape. So beneficial organisms that are going to help control pests without actually using a chemical intervention. Once we get past that, if our pest problems still continue, then we get into the chemical realm. And that's where we go from like soft chemicals to hard chemicals. So what we're going to be covering tonight with the templates that we're going to be talking about is how to actually make the decision that I need to become interventive. I need to start incorporating a biological organism or a chemical management plan in order to take control over my problem, my pest problem, because it's getting out of control and I'm going to start losing my crop or losing money is another way of looking at that, an economic loss. So that's a little bit of a recap on the IPM triangle. So with IPM, it is really critical that you have good data to make these decisions. You just don't go in and just start throwing money at the problem by incorporating biological organisms like predatory insects or spending a bunch of money on pesticides when in actuality the problem may not be harmful to your crop in the economic manner. It may just be a presence of pests. But you have to have data in order to determine all of that. And that's where scouting comes in. So in scouting, we use things like sticky cards, which are things that insects stick to. You deploy them out into a field or they're used extensively in the greenhouse industry. Put them in a greenhouse, leave them there for a week or two, and then come back and collect them, and then count the insects, the types and the numbers of insects on the card. Identify who your predators are, because some of them are going to be good guys, and then who the bad guys are that may be potentially harming your pest. We can also use things like sweep nets, like you see in this picture on the bottom right. And then in addition, we want to know if all of these stink bugs that are on this tomato right here, is that an actual harmful number of stink bugs? Is that, obviously in this situation, this is kind of over exaggerated for impression on you. But, if you see something like this, obviously you could pick this off and throw that away and get rid of those stink bugs. But the idea here is this a problem that's actually harming your crop and costing you money as a farmer? Because again, there's always going to be pests in the environment. We're trying to manage them at an acceptable level where they're not causing harm to our overall economic crop. Now, overall, what scouting does and what this type of a thing does for you as a farmer is it basically lets you answer the who, what, when, where, and why. So, who is the pest that's actually causing the problem? So by scouting and collecting data, whether it be through sweep nets or through traps like sticky cards, these types of things are going to help you identify who the problem is. Most of the time with pest problems, We see the symptoms. We don't see the pest. So you'll walk out to your crop one day and there's going to be a bunch of holes in your collard leaves. And you're going to be like, well, what the heck ate all those holes? I don't see anything here. And so this, by doing these types of collections, you're able to identify who is actually causing the problem in this situation. And obviously, you're going to have to do a little bit of your own work on this end. You see a pest on a sticky card, then you need to identify what it is. And sometimes that can be like reaching out to your local extension office and saying, hey, I have this pest in my crop and I need help identifying it. When I worked for extension, I did that a lot for people. They'd send me pictures on their phones and things like that of pests and ask me, what is this that I'm seeing? That was part of my job. So, you can always find help for this as well. And then we talked about in part one, the guides that you can use as well, both online and print guides that you can use to help identify pests in crops. This is going to then influence what are the management tactics that are actually effective for this pest. So, you may have Colorado potato beetle, like you see her on the bottom left photo. You may have Colorado potato beetle and a big problem with that. But if you didn't know who it was, you could be using strategies that are totally inappropriate for that particular pest. Not all pests are susceptible to all chemistries. Not all pests are susceptible to all predators or parasitic insects. They are oftentimes, some are susceptible to some mechanisms and some are susceptible to others. And so that's something that you need to know, and that's something that scouting is going to help you with. The next thing that it's going to help you identify is when should I employ a management strategy? So oftentimes there are in all of the insects you're going to be dealing with that are pests, there's life stages. There's an egg stage, there's a juvenile stage, and then there's an adult stage. And each one of those stages, sometimes those stages can occur in different places, meaning that they are susceptible to different management strategies based on where they're actually at. And the example I'm using here is in asparagus. So asparagus minor is this little tiny fly you see over here on the bottom left. This fly is what we call a minor. And so in its adult stage, it flies around all over asparagus. And if you were to use, say, like a broad spectrum insecticide to spray a crop with, it would be highly effective on those adults. But on the bottom right picture, what you see here is the bottom of a mature asparagus stem. And what you see are those brown sections that are kind of meandering up that right stalk. Those are mines. And that's actually the juvenile stage of that fly. The juvenile stage occurs inside of the asparagus stem and is completely impervious to anything you spray at it. You could dump $1 million in pesticide on that crop, and you're not going to kill one of those asparagus miners when they're in that juvenile stage. So knowing when I should be applying these is really important. And oftentimes, you may be thinking to yourself, well, how do I know when I have all these adult flies? In many crops, a lot of your extension agencies have actually developed tools to help you determine when certain life stages are occurring. Those are called degree days, is what we calculate those in as scientists. And basically, a lot of degree day models are out there for specific states, for specific crops, for specific pests that will help you calculate how many days have I actually seen from the start of the season to now? How many degree days have I seen for this pest? And what stage is it actually going to be in? So there's a lot of that work that's been done for you. But knowing who it is, what management tactics are available to you, and when I should employ those tactics is really important. But the identification of the organism oftentimes is going to lead you down the path of a lot of resources available for all these different crops that you work in. The other thing that scouting is going to help you identify is where is the pest a problem. Some pests are soil dwelling. So things like like crabid beetles are soil dwelling, or things like cutworms, like you see here in this bottom left picture. Those are soil dwelling insects, and so they're often a problem down in the soil. There's things that are going to like lop off your plants. All of a sudden you're just going to have a plant that's totally lopped off at the base, like you see this corn right here, and that is a soil-borne pest. Crabid beetles are oftentimes predators, but they're also called ground beetles, but they're oftentimes predators, but they are sometimes seed predators as well. So at planting, when you plant a field and all of a sudden you don't have a good germination, you could have a lot of crabid beetles in your soil that are actually feeding on the seeds that you're planting. But you need to know where this is occurring. Is it inside of a leaf like you see here? This is another example of a miner where you can see the mines in this citrus leaf going all the way there, and then you can see right underneath the furthest layer of that leaf, you have a little tiny maggot in there. So that is a fly larva that's inside of that leaf. And then you have things that are like, like this worm, this caterpillar that you see over here. These types of things are things that oftentimes are easy to see because they're oftentimes on the leaves that they're feeding on, but they're on the leaf material, right? So you have many different areas here. It could be in the leaf, it could be in the soil, it could be on the leaf, but you need to know where that's at, and scouting is going to help you with that. And then the last part of all of this recap is the why, right? Why should I be managing this pest? It's a big question because the why is kind of it's up to you as a farmer. This is where things kind of rely on your understanding of your crop. As a farmer, whether you're a small farmer, medium scale, or large farmer, you need to know your crop better than anybody. A lot of that comes with experience, but a lot of it also comes with knowing the market and actually putting yourself out there in the market. So becoming active, I would say, and like going to farmers markets and seeing like what are the prices of certain crops, and what could I get potentially if I were to start raising this crop. This is also where business planning really comes in well, is understanding the why. And it always comes down to economics. I'll be real honest. I've been working in sustainable agriculture. This is my 31st year. And it always comes down to economics. If you're not able to pay the bills, if you're not able to survive off of your income as a farmer, you're not going to be a farmer very long. And so you need to make sure that you understand why you're doing things. And that's I think one of the most important parts about scouting and collecting data and making good decision-making tools to help you determine pest management outcomes, because you don't want to just be wasting money. And if you're working full time as a farmer, money is not something that's just, you don't have slush funds sitting around. Farming is a very lean lifestyle for most farmers. And so you don't have a lot of disposable income. So just going and buying pesticides to try and take care of a problem that maybe you could have taken care of well before that through a much more inexpensive means that doesn't involve chemical intervention, that's what you're really after. But in all, it's got to make you money, and that's where the economics come in, and that's why scouting is so important. So let's get into what today is all about. So we've done a little recap here for the first 15 minutes of part one, and let's jump into what the meat and potatoes are of today. So scouting records and actually developing a tool to help you determine, do I need to take action because of a certain pest problem, or when should I take action to make sure that I don't lose my crop to economic damage? So we're going to talk about all of these points, and this is the template that was sent out to those of you that were registered and will be made available to everybody else once we put this on YouTube later this week. But what we're going to be covering today are these particular data points. So things like fundamentally dates, like what collection methods we're using to actually scout. What are our visual observations that we're seeing? We're going to quantify our observations through this tool, and then we're going to basically determine damage level. And this is your perceived loss. This is where you knowing your crop better than anybody comes into play. Going to those farmers markets and doing your research and looking at what produce is being sold, and look at it. Visually look at it. If you're going to grow collards, look at people selling collards and look at what the level of damage is on them, and to ask yourself, would I buy that or would I not because of the pest damage on it? There's always an acceptable level of damage. And I'll be real honest, box stores, there is very little acceptable level of damage for crops. Things have to look perfect when they're in a grocery store. And that is just an artifact of what box stores want and what consumers demand. But those people who are doing direct consumer, who are buying from you as a farmer, oftentimes at farmers markets, though that clientele is much more understanding of what goes into sustainable farming, and oftentimes will be much more acceptable of some damage than other consumers, like those that are shopping at box stores. This is the reality of kind of that nature of what clientele goes to each one of these types of vendors. So you should be able to, at some point, be able to determine by looking at a crop, whether it's a head of lettuce or a cabbage or a tomato, is this marketable or not? And that's what we have to get at when we're talking about perceived damage, is you being able to determine, can I sell this or not? So that's what we're going to be covering in the tool. So this is the next step. All right, so here's our template. And we're going to be filling this out tonight. So we're going to be covering this. We'll fill out this entire template for an entire year. And then what we'll do is we'll develop a graph that's basically going to tell us, when I get so many of these pests on this sticky card, I need to do some sort of interventive action, meaning a biological or chemical intervention. So we're going to go through that tonight. So that's what we're heading for tonight. So a lot of excitement as we fill out a form together. All right, so we're going to start with the fundamentals. So this is the same form you have. The plant date, 5/31/25, is going to be our plant date for this year. And so that is what I'm putting in my records. You want to always make sure you include the year as well. Now, good record keeping, not only does it help with pest management decisions, it is also really great for business records. It's also great for when you're participating in USDA programs. A lot of insurance programs will require records. And so this is an excellent way to also make your farm very eligible for those other types of support programs that are out there, like the EQIP program through USDA that oftentimes will help with cost share, things like pollinator habitat, livestock fencing, all of those types of things. So this will serve you in many different respects, not just for yourself personally, but also for you professionally. All right, we're going to fill in what is our crop for this season. And I'm going to grow collards this year. That's what I've decided I'm going to develop this tool with. Now, you're going to do this for every single crop you grow, and it may even be variety specific because some varieties of plants are sometimes more susceptible to pests than others. So you may want to also do this for variety. This is a lot of information, but this is you as a farmer. This is going to take years of development over time. This is an investment in your future. Let's look at it that way by taking this type of serious data. So the crop this year is collards, and then I'm also going to do it by variety because maybe I'm growing a few different varieties and maybe I'm having a problem with pests on one variety more than another. I'm going to be growing tiger variety from Johnny Seeds. Now, we're going to start with scouting dates. Now, I'm going to be using this for a sticky card. Now, for whatever collection mechanism you're using, like we talked about in part one of this webinar, whether it be a sweep net, an aspirator, whether it be sticky cards, whether it be a light trap, whether it be a delta trap, whatever it is you're using, you're going to do one of these for every single one of those methods. So we're going to start with sticky cards on this one because they're oftentimes the easiest one to use. Sticky cards, you generally want to deploy them for 1 to 2 weeks, depending on the crop. If you put one out for a week and it's saturated with insects, pull it every week. If you can get 2 weeks out of it, get 2 weeks out of it. Whatever works for your schedule. I'm going to be doing this weekly. And so let's say that I deployed my sticky cards last week, and this is the first week I'm coming to collect them for data. So 6/28/25. So I let my crop grow out a little bit. It's grown for about a month. So now it's above ground and kind of rocking and rolling. And the insect that I want to look at, the one that I've been having problems with maybe historically, is flea beetle. Flea beetle is if you're growing things like collards or Swiss chard or anything that's leafy and needs to look good for your marketability, this is oftentimes a major pest. And the damage that it causes, and I'm going to just show you for those of you who are not familiar with flea beetle, this is your flea beetle right here. And this is a collard, a shot of a collard green leaf right here. And what you see are these shot holes. It looks like someone took a shot at it with number 7 bird shot or something like that. And it just leaves all of these holes. Now, it is still edible and fine to eat, but marketability wise, this is going to be harder to sell. You would not be able to sell this in Walmart. Hands down, their buyer would not take this from you. But you need to understand that, there is a level of acceptability here. If it's just the outside leaves, that are kind of getting it and you still have good interior leaves that you can harvest, maybe this is not a problem at all. But if this is what all of your collard leaves look like, that's a problem. This could become unmarketable. So that's your flea beetle. And this is a close-up of it here at the bottom right. They are numerous when they are around, and so they can do a lot of damage very quickly. So back to our form here. So I identified that the pest I'm going after is flea beetle. That is what's causing my problem. And maybe I had called an extension agent out to my farm to help me identify that to get started. Maybe I just couldn't figure out what the damage was. That's what those folks are there for. Use them. That's why there's county offices. Use those extension agents and their expertise. They're there for your help. And so the next thing that we're going to do after we've identified the insect is we're going to identify the scouting method. So this may be something that you did a little search on the internet after you identified the pest. You said, searched Google for what is the best scouting method for flea beetles. And it probably gave you a whole bunch of choices after that. And so, you can go from something like that, or again, reach out to your extension agent and say, I got some flea beetles. I'm trying to figure out what the best scouting method is for this. And it could be a sweep net where you actually are sweeping a crop, but a lot of times sweep nets only really work in kind of taller crops that they can actually take like being hit by a sweep net. So like the example I used of asparagus, that's what we used in mature asparagus. When it ferns out, you can sweep that all day long and you're not really damaging the crop. With collards, if you were to use a sweep net, you're going to be knocking leaves off all over the place. So a sticky card would be the most appropriate. If you're working in greenhouses, in any type of a greenhouse situation, sticky cards are pretty much the method that you're going to use for collection. They are very versatile, very inexpensive to purchase, and very easy to deploy and collect. So we're going to use, and you see I have three categories here under scouting method. I'm going to use the method. I'm going to write that down, which is a sticky trap. Then I'm going to quantify the number of traps I put in this crop. And I'm just going to say 6 traps is what we used in this crop. And I have, and basically, and I'm going to show you in the next slide here, I have 5 rows that I've got in collards, and I'm going to deploy 6 traps in those 5 rows randomly. And then I'm going to put my collection pattern, and I put 2 traps per row every other row. And this can be anything that you want to decide. The most important part about this scouting and deploying these types of mechanisms is that they're randomized. That you're not doing the same thing every single time, because if you just put the same sticky card in the same location every single week, a lot of times pest patterns as they grow in a situation, especially in controlled environments, they start in one area and then spread. And so if you're not randomizing these traps all the time, you're not going to get a full scope of what's actually happening in your crop. So that's a really important part about this. Now, I'm going to switch to another screen here. And if you have your template that I sent to you, this was one of the pages that was in there, and that's your field map. And so this is where I'm actually going to visually, physically map out on this diagram. And you can just use those squares and, use a pen and just write in whatever your crop looks like. Maybe you don't, run crops on rows. Maybe you're running a more diversified operation. But whatever it looks like, you're going to kind of put a map out on that. And this is for your record so that when you go back to this next season, you know exactly what you did so that you can have uniformity between years when it comes to data collection. On my notes, I put I randomized sticky traps each week within rows. And so you can see the black kind of diamonds. Those are my sticky traps. Those are moving every single week within those rows. And then I also put my information on the top here. I've got my crop, I've got my variety, I've got my pests, and then I've also got the cardinal direction north right there. So you've got all that information on here. So that is my field map, and that kind of matches what I have in the scouting method. So again, 2 traps per row, every other row was what we saw in that diagram. All right, so now I deployed my card a week ago. This is my data collection day, so I'm collecting all of my cards. Here's some tricks. For those of you that are going to use sticky cards, which to get started, I would highly recommend this for just about any crop. Just about any crop, you can put sticky cards on and get some information. So if you're new to scouting, that is definitely the easiest way to start. And what you want to get are these, they're usually about 3x6 or 4x6 cards, kind of like an index card. And for the most part, they're going to be yellow. There are blue sticky cards as well. Those are used specifically for thrips because thrips are attracted to the color blue. If you're not growing flower crops, if you're not in floriculture, you're not probably going to be dealing with thrips because thrips typically attack flowers. And for like, growers that sell cut flowers and things like that. And I used to be an evaluator for Baltagawa growers on cut flowers, Lysianthus specifically. Those flowers have to be perfect when they're going to a florist, and you cannot have any damage from thrips. And so blue cards are used for thrips, but yellow cards work for pretty much everything else. And so what you're going to do when you collect these yellow cards is you're also going to have like a quart plastic bag with no labels on it. No, meaning there's none of that like pre-written text on those bags. They're just clear bags. And you're going to slide those sticky cards in that bag really carefully and then seal it up. And the reason you do that is because you're going to be using these sticky cards and counting them, and they are very sticky. And so they need to go in something that you can handle them easily and you can store them. After you collect these cards, you're going to put them in the freezer if you're not able to process them right away. And they can stay in the freezer in perpetuity, but you're going to want to get to these at some point because you normally want to process these as they're coming in so you know what's going on in the crop. But that's how you're going to handle your sticky cards. So I went out and I collected my 6 sticky cards. And what I did is on those sticky cards, I counted the number of flea beetles on every single sticky card. And what I came up with was 90 beetles for 6 sticky cards. Now I did some fancy math. 90 divided by 6 gave me 15 beetles per trap. And that's what I'm after. I'm after the average. What is the average number of pests per trap? I've got that number. Great. Now I have it in my data collection sheet here. The next thing I'm going to do is ask myself, I'm going to look at my crop, I'm going to walk my crop, and I'm going to look it over. And from a general standpoint, I'm going to ask myself, can I sell this crop? And that's what the next column is. Can I sell this crop? Is it causing economic loss? The answer is yes or no. And that's your judgment call. Can I sell that crop or not? And if the answer is no, is there economic loss? If the answer is no, there's not economic loss. Yes, I can sell my crop. Then you don't have to do anything. At this point, the pest is not causing you economic loss. It has not gotten bad enough to where it's causing a problem. It's there. And that's why we do the preventative measures like good crop rotation and things like that to help kind of feed these problems off before they start. But there's always going to be there in some aspect. Maybe you'll get some zero counts here and there, but eventually they're going to show up if they've been a historical problem for you. So the answer is no right now. So on June 28th, I can say, no, it's not causing me economic harm. So I don't have to take any action. My tools that I've employed, my cultural tools, my mechanical tools, like my traps and things like that, they're working. And they're keeping the pest at an acceptable level at this point. I don't need to buy a pesticide to spray for it. I don't need to buy a biological like a predator to do it either. Everything's fine. This is part of sustainable agriculture. You're always going to have good guys and bad guys in the landscape. It's the balance that matters. All right, so now we're going to speed through this. The next line is going to be 7.5. So a week later, I did the same thing. So when I collected my sticky traps on the 28th, I also deployed new sticky traps, randomized them again within my crop on the same pattern I said before, and boom, we've got our next data collection day on 7.5. Same pest, it's going to be flea beetle the whole season. Same method, we didn't change anything there because we want consistency between these data points. If you start putting more traps out, you may get more data, but it may also skew things. Uniformity and replicability is important in data collection. You want to be using the same methods over and over again to help you make these decisions. So I did again, Here we had the 2 traps per row, every other row. 100 beetles I found this time per 6 sticky traps, which comes out to 17 beetles per trap. So a little bit of an increase this week over last week, but we're still saying that it's not causing us economic loss. That's fantastic. It means we don't have to do anything. Everything is working like it should right now. Now, let's go to the next day. 7/12, we come out the week later, and I live in the Upper Peninsula of Michigan. This is a very reasonable time frame for us to start data collection is at the end of June. But by July, because our seasons are so short, oftentimes things pop off real quickly in our landscape. Pests will come out of nowhere because the seasons are so short. For those of you who live in more temperate climates, a lot of times this is a more prolonged process. You don't go from like 1 week to the next where you go from like no problem at all to a massive problem. But in my situation, this is a very realistic example. So on 7/12, same method, same pest, I picked up 310 beetles on my 6 sticky traps. That's a dramatic increase. That is 52 beetles per trap. So right now, I went from having, half a dozen beetles on each side of that sticky trap to literally both sides being covered in beetles over the course of a week. My economic loss, I am actually starting to see significant damage on my crop now. I am saying, yes, I am at the point where this is causing me economic loss. Now, in this example, what we're doing is we're building a data set to use in the future. Now, you could make a decision right here to do something also because you now have said, we said in the data, yes, this is too much. So not only is this historical, meaning you're going to come back to this and use this data later on, but it's also something you can use right now because you are making that decision. That perceived loss is there. You're losing money at this point. So I've marked, yes, it is causing me economic loss. And I also took action. And what I took action on was using kind of a more of a softer approach. So I used an insecticidal soap. The product is called Impede. And according to the label, because you should always follow the label on anything you are using, whether it is a botanical soap, an organic pesticide, or a conventional pesticide, whatever it is, that label is a legally binding document. You have to abide by the rules, or else you run the risk of harming yourself or your crop or the environment. So I used insecticidal soap, that Impede product. I sprayed it as per the labeled rate of 2.5 milliliters per gallon of water, and I sprayed 20 gallons total of solution on my crop. Now, that's important data to have. If you live in Michigan, you may have heard of the Michigan Agriculture and Environmental Assurance Program, or the MEAP program. The MEAP is kind of our sustainable farming practices kind of verification process here in the state of Michigan. So like my farm is verified for several different crops and systems through MEAP. And one of the big things that they require are records like this. What was the rate you sprayed at? When did you spray? What did you spray? These are all things that we keep every single time anything touches that field, whether it's fertilizer or pesticide or fungicide. It gets documented, and it has to be, in order for us to maintain our verification. If you're going for like a USDA organic certification, this type of data is absolutely necessary in order to maintain your certification. So keeping these types of detailed records are important, but it also is helping you keep track of what did I actually use, because maybe this isn't effective. Maybe you come back a couple weeks later and this problem is way out, even more out of control. And now you know that, well, that Impede really didn't do anything for those flea beetles. All right, so let's move on. So we did spray on 7/12. On 7/19, when we came back out, again, same collection method and everything, we saw 200 beetles on those 6 sticky traps. So we see a significant reduction, a third less beetles in the landscape at this point after that insecticidal soap. So we got some knockdown. 33 beetles per trap is what we're seeing. And when we look at the crop, we're not seeing, that excessive economic loss anymore. It's not persisting. We may have had some economic loss on that 1 week, and maybe we had to cull a few plants, but overall, we still have a marketable crop right now. So we're good with the damage right now. It's not causing excessive damage at this level. The next week we come out on the 26th, and we're at 215 beetles per sticky trap, or for our 6 sticky traps, so 36 beetles per trap. Now, that's a little bit of a bump from the previous week, but it's not excessive, right? I mean, it's a little bit more. This could even be just a sampling error, or just kind of a margin of error that's just embedded in this type of collection. There's always going to be a little bit of error in everything that we do. So there's no action or no economic loss taken, or no economic loss happening, and no action taken here. All right, so let's go on to this next day, which is 8/25, or excuse me, 8/2 of 2025. Same methods, but this week we have 419 beetles per 6 sticky traps. That's 70 beetles per trap. We already answered when we had 52 that yes, I was seeing economic damage. So without even looking at the crop, if you have that many on there, you should definitely be able to say, yes, it's causing economic damage, because at 52, it was causing economic damage. So yes, that's economic damage. Now, because MP did not really work last time, we got a little bit of knockdown, but it didn't last for more than 3 weeks. We saw a resurgence of the pest, and we really never saw a dramatic knockdown. And so because that's the case, I may now, based on this data, want to take a more aggressive approach. Now, I'm still, and this is me personally, it takes a lot to get to the very top of that triangle where you're using a synthetic chemistry. We don't even have any of those on hand on our farm. We don't even keep them around, because we just never are going to get to that point, because we're constantly doing this type of work. But we do want to get a little more serious here. So the insecticidal soaps are kind of like the very low end of like an application of a what we would consider a pesticide, but it's a very low, very soft intervention. The next step up is kind of biologicals. And so what I'm going to be looking at for this next application is something that's biological, something that is, in this case, a fungus. Maybe it's a predator insect that you're going to release for a specific pest that you're dealing with. If you're dealing with aphids, maybe it's lady beetles that you're going to be releasing in this situation. But in my case, I'm always looking for kind of the most organic, most kind of uh, I'd say like environmentally driven solutions. And so Bavaria bassiana is a fungus that is what we call an entomopathogenic fungus. It's a fungus that attacks insects. And so the product name is Botanigard, and so that's what we're going to apply this time. So I'm doing a soil drench of Botanigard because flea beetles, part of their life cycle is in the soil, and they spend a lot of time on that soil. And so we're going to do 2 milliliters per 1 gallon of water is the application rate on the label, and 20 gallons of total solution like we did before, and we're going to apply it. So next week we come back, and I'm going to make this a lot quicker on this slide. We're not going to go through the rest of the year. We're gonna go through it in one shot. So the rest of the year, what I saw after that application of Bavaria bassiana, and always keep in mind, biologicals take a little bit of time. There's a little bit of lag for them to get started in the crop before they really start to take hold and do a really good job. So be patient with biologicals. You're going to have to give them a few weeks. But in this case, you can see that first week I came back on August 9th, I had 205 beetles from that previous 400 plus beetles that I had. So 34 beetles per trap. The next week we come out 27 beetles per trap. The week after, 17 beetles per trap. And we see that continued decrease over the course of the season, which oftentimes is indicative of biologicals. Once they take hold, as long as there is a pest there, that is a food source for them. And so as long as the pest is there, biological organisms that are, what we call biological controls, those organisms are constantly growing, constantly developing. And a lot of organisms that we deal with, especially when we get into things like predatory nematodes, it's an exponential process. Like one nematode goes into an insect and 1,000 come out. And so over time, these populations build of these biological organisms and really take hold of the pest pressure. It's one of the reasons why I'm such a big advocate of biological control. And it's an area that I've spent, decades working. And so it's something I really believe in. So this is an example of how you would collect data over the course of a season for a specific crop and a specific pest. And now you're probably asking yourself, well, great, I have this page of all these numbers and things that I did. What do I do with them? So let's answer that question here. So what you're going to do is you're going to take all of the average numbers that you collected. So like on this screen here, 34 beetles per trap, 27 beetles per trap, 17 beetles per trap. You're going to take all those averages and you're going to plot them on a graph. And I even sent you in the templates a graph template. So just it's basically a sheet of graph paper that looks like this without the graph on it. What you're going to do is you're going to take your dates and starting with the very first date you collected data down here on the bottom left, you're going to put on each one of these lines a date. And this is your x-axis. So the x-axis is your scouting date. The y-axis is going to be the average number of insects counted per unit, so per sticky card in this situation. And you can see I have those labeled 20, 40, 60, and 80. So I went through my entire data sheet for the year, and this is something you're going to do at the end of the year, and plotted those numbers. So on 628, and we're just going to use averages here because I don't have the sheet right in front of me, but we can go back to it certainly. So let's see. So we're going to look like 15 beetles per trap, 17 beetles per trap, 52 beetles per trap. That's what we're plotting out here. And that's what we've got here. So come back here. I plotted all those numbers and you can see you've got these like highs and lows. So, in the beginning of the season, it started out real low. We had that real big spike where we said, yes, we're having economic damage right at that point on 7/12. And then it dropped back down after we did that first application of MP'd. Then it kind of just started to rise back up on 7/26. And then we saw that spike again on 8/2. And that's when we applied Bavaria bassiana, or Botanigard was the product name. And then we saw a drop off the rest of the season. So when we were plotting this all, or when we were writing all this down in our data, we also asked ourselves those perceived questions of economic loss. On 2 of the dates that we collected, we said we were incurring economic loss, meaning we were having damage that was occurring to our plants that was affecting the marketability of those plants, meaning I can't sell that anymore because it's so damaged. When we started seeing that, we always answered yes. And that's also when we started to take an interventive action. So those two numbers really mean something. They're very important numbers for us because that is when we said that's too much. The crop can't take anymore. So you're going to start with 52, which was the low end of that, and you're going to draw a line straight across. And I'm using red here for a specific reason. So I draw a red line straight across at 52 because I know 52 was the lowest point where I said I was seeing economic loss. This is what we call the economic threshold. This is for your economic loss threshold. This is the point at which your crop is unmarketable. And you have determined this by your own eyes and your own data collection that that was too much damage to that crop at that point. Now, over years of collecting data, you're going to revise this every single year. And this, your economic loss threshold may change. It may change because maybe you're starting to sell to a big box store at this point. Maybe you've grown to a scale where I can sell something to Myers or Kroger or Walmart, and their standard is higher for damage on crops. And so maybe my economic loss drops because I need cleaner crops. Or maybe it goes up because my clientele doesn't really just seem to care that there's a few, flea beetle marks on a few collard leaves. And so maybe it may go up. This will change over time. This is not static. This is dynamic. But what we're doing is we're establishing it for this season, and the next season we'll incorporate that data and refine this further and further. And that's exactly how we do it in the research community. I mean, there's a little more fancier tools that we use than this, but it's essentially the same idea. You collect data, you plot it, and then you make decisions based on those plots. Now, that's our economic loss. We don't want to ever get to that point. The whole goal of this exercise is not to incur economic loss. So it's great that well, yeah, when I hit 52, when I see 52 average on those sticky cards, I know I'm hitting economic loss and I need to do something. But we don't ever want to get there. And the good thing about being a good farmer is making sure that you never get to the point where you have an economic loss. It's always going to happen at some point, but that's the goal, is not to get into that situation. So what we're going to do, and this is just kind of just a standard kind of method that you can use. Take that high number, the high of, or the low of the high, 52 is the number we're working with. That's that data point on 712 right there. We're going to take that number and we're going to basically cut it by 20%. Take that number, cut it by 20%, and draw a line there. We're going to draw it right at about 40. That's our yellow line. 40 beetles per trap in this situation, 20% under our economic threshold, is what we are going to call an action threshold. And that is the point at which you need to take management action to prevent economic loss. And this is going to be one of those interventive actions. You've already been doing your cultural and your mechanical stuff. That's just part of being a good farmer, is just getting that stuff out there. But in this situation, this is where you need to start taking action in the form of maybe an intervention like a biological, or maybe a soft, chemical, something like that. By doing that, when you hit 40, and remember, you're collecting this data every week. So you collect a week where the average is 40 and you're like, oh my goodness, I need to do something right now. This is my action threshold. Go out there, do your application, do your release of good insects or good fungus or good nematodes. And that's when you take that action, is right at that threshold. So this is a really powerful tool. Being able to know when you need to do something based on data collection, rather than just going out to the crop one day and saying, oh my gosh, I'm done. I'm finished for the season. That's a terrible feeling as a farmer. Having to till under a crop is one of the worst feelings that you'll come around, because you've put all that money, blood, sweat, and tears into that crop, and having to till it under at the end of the season it's devastating. So this is a way to prevent that from happening, by being able to know when I should be taking action before it becomes a problem. That's a powerful tool in your toolbox. Now, this is going to be replicated for every crop that you're growing and every pest that is a major pest that you're dealing with. That may seem like a Herculean task, but most of us are not growing 100 different crops. Now, I know some diversified small farmers get kind of crazy with certain crops. Some tomato folks really love their tomatoes and may grow like 20 different varieties of tomatoes. All those tomatoes may be susceptible to something different. You may have to do different data collection for each one of those varieties. Maybe not, but it just depends on the crop. And this is going to be kind of a trial and error process. You're going to start this out. Data collection is always a powerful tool, like I mentioned. It's not like you collecting all this data is just going to go to waste if you don't ever get to this point. For your records, for your certifications and things like that, verifications through the state, those types of things, this is going to be imperative to have good data. But being able to develop a graph that helps you make management decisions, that's taking that data to a whole nother level. And this is a very simplified way to do that. All right, so to summarize for tonight, and we'll have a little bit of time here for questions if we've got any. Really, when you're thinking about jumping into agriculture, oftentimes we think about what we want to grow, how we're going to sell it, all of those great, fantastic things, the money we're going to make this year off of all these crops I'm going to be growing. But the reality is that a lot more goes into farming than just knowing a crop and being able to sell it at a market. A lot of it has to do with being able to determine who the good guys and who the bad guys are in the crop and how they're affecting the crop. And oftentimes, the idea of being able to develop a management plan based on good decision making tools and not just flying by the seat of your pants can really make or break an enterprise. Like I said, I've been in ag for a very long time, 3 decades. And over that time, I have worked for a lot of really great farms. I've also worked for a lot of farms that were well intentioned, but just did not have the decision making capability to make a go of it. And in small scale agriculture, the 5 year mark is a benchmark. Most small scale agricultural producers fail within the first 5 years. And farming is not a cheap endeavor. It is expensive, and the money is not great coming back in on it. We buy everything retail and sell it wholesale is the phrase. And so there's a lot of times where farming becomes very difficult, but tools like this can help you really make a difference when it comes to inputs, when it comes to pest management, and not just throwing money away for trying to take care of a problem when you don't actually know really what's going on. I've seen a lot of, issues over the years where people are just spraying pesticides because they see damage and they don't know what the pest is. They're not even sure if the pesticide is going to work on it. It's just something they bought from Home Depot and, it said it kills bugs. All of these different pesticides and, whether it's organic or conventional, all of them are going to say who this is effective on. And so that's where that coming into knowing who you're dealing with is really important. And that's where scouting comes into play. This picture right here that you see here is a prime example of why scouting is also important, because there are a lot of good guys out in that landscape that are doing hard work for you managing pests. When I was doing research in asparagus I guess it was in the 2010s, this was one of the main predators that we found that was attacking asparagus beetle, and that's what we call a spined soldier bug right there, the big bug that you see there. And hanging off of its mouth parts is a larva of a asparagus beetle, and it is literally sucking the insides out of that asparagus beetle. Major predator in asparagus in Michigan. This is a native stink bug. So this is also looks like brown marmorated stink bug, which we covered in part 1 of this webinar. So this is one of those ones that looks like a bad guy, but is actually a good guy. You don't want to be killing all of these good guys. And when we just go and spray pesticides on things, it's exactly what we're doing. We're broad spectrum insecticides kill everything. They're not targeted, and that's what we're trying to avoid, is just going in, like I said, guns blazing, without really knowing who the target is. All right, so